Welcome back to session 11 of GED Science Mastery. I am glad you are here. Your body is a team of systems that all have to work together, and the GED's human health theme leans on two big ideas: what each major system does, and how the body keeps its internal conditions steady. That steadiness has a name: homeostasis. Master the feedback loop behind it, and you can reason your way through a whole family of health questions. Let's meet the team. Here is the big idea in plain words: no system works alone. The lungs bring in oxygen, the heart pumps it, the blood delivers it to every cell, and the nervous system coordinates the whole operation. And to stay alive, the body has to hold certain conditions steady, things like temperature and blood sugar. It does this with feedback. A sensor notices a change, and the body responds in a way that pushes conditions back toward normal. Teamwork keeps you running. Feedback keeps you steady. Let's match a few systems to their jobs, because the GED loves that. The circulatory system, the heart and blood vessels, transports blood, oxygen, and nutrients. The respiratory system, the lungs, exchanges oxygen and carbon dioxide with the air. The digestive system breaks food down into nutrients the body can absorb. The nervous system, brain and nerves, senses and coordinates fast responses. And the endocrine system releases hormones like insulin for slower control. Learn the job, and the system's name follows. Here is the engine of homeostasis, the negative feedback loop. It has three parts. First, a sensor detects a change from normal. Second, a control center, often the brain, decides how to respond. Third, an effector carries out the response. And crucially, that response opposes the original change, pushing conditions back to normal. The word negative is the key. The response counteracts the change rather than adding to it. Sensor, control center, response, and back to normal. That loop keeps you alive. Let's see the loop work twice. First, temperature. If you get too hot, sensors notice, and your body responds by sweating and widening blood vessels near the skin, which releases heat and cools you back to normal. Notice, evaporating sweat cools you, it does not warm you. Second, blood sugar. After a meal, blood sugar rises. The pancreas responds by releasing insulin, which helps your cells take in the sugar, so blood sugar falls back to normal. Same loop, two different jobs, always pushing back toward normal. Let's read a real GED-style measurement. A student measured her heart rate 3 times. At rest, right after 2 minutes of jumping jacks, and again after 5 minutes of sitting to recover. Look at the bars. At rest, her heart beat 70 times per minute. Right after exercise, it jumped to 140. And after 5 minutes of recovery, it had come back down to 90. So the pattern is 70, then a big spike to 140, then a fall back towards 70. In a moment, we will explain that shape with feedback. Let's explain that shape with our method. Why did the heart rate rise during exercise and then fall afterward? Read. The rate went from 70 up to 140 during exercise, then dropped towards 70, landing at 90 during recovery. Choose. During exercise, the muscles need more oxygen, so the heart beats faster to deliver it. When exercise stops, the demand falls, and negative feedback brings the rate back down toward the resting value. Check. The recovery value, 90, is heading back toward the resting 70, exactly what homeostasis predicts. It is not fully returned yet, which is normal after just 5 minutes. One more idea that ties it together: levels of organization. Cells group into tissues. Tissues build organs. Organs team up into organ systems. And all the systems together make the whole organism. You. That is why systems must cooperate. Oxygen breathed in by the respiratory system rides on blood pumped by the circulatory system to reach every single cell. When you see a health question, ask which systems are working together and how the body is keeping itself steady. Let's lock in the traps. 1. Thinking one system acts alone. No, systems constantly cooperate. 2. Thinking negative feedback adds to a change. No, it opposes and reverses the change. 3. Expecting recovery to be instant. No, returning to normal takes time. 4. Thinking sweating warms you. No, evaporating sweat cools you. The recap. Homeostasis keeps conditions steady through negative feedback. Stimulus, sensor, response, and back to normal. Wonderful work today. You can now match systems to their jobs, trace a negative feedback loop, and explain the heart rate curve. Your practice for this session is the 10 questions attached to this lesson. Answer them from memory, and for any feedback question, just ask, does the response push conditions back toward normal? To read the full lesson notes and practice more GED science questions, visit the course page at www.bridgetoexam.com. I am proud of you. I will see you in session 12, where we cover health, disease, nutrition, and the body's defenses. Keep going. You are doing great.